Hi, welcome to the fourth tutorial of the Machine Tool Flow Creator tutorial series. This episode will be all about connectivity with OPC UA. In the last episodes you learned how to work with data coming from the cinematic, and this episode you will learn how to provide this data to MES or ERP systems using OPC UA. Companion specifications are a great way to provide data in a standardized way with OPC UA. For that, we need a transformation engine which transforms the machine-specific data into the standardized way. And we will do exactly that in this tutorial. And before we do that, let's talk about the general way to program such a provider application.
Let's do a short recap on OPC UA. OPC Unified Architecture is an extensible and open communication standard which is mostly used for industrial systems, and the goal is to connect the OT world with the IT world, so to connect the sensor level to the IT systems of the company. And OPC UA is used to provide information models which contain different variables from machines, sensors and devices. And as I already told you, companion specifications are a great way to standardize a certain machine type for an industry. In the machine tool industry, there are three different companion specifications: UA for machine tools, UA for CNC, and MT Connect. The industrial edge for machine tools OPC UA server is the perfect tool to access the specific machine data and transform it to fit the standard. When you want to implement your own OPC UA solution, the first step is to do the modeling in Siemens OPC UA modeling editor. Then you will have an XML model and you need to encode that to base64, and we can import this model into the app configuration of the provider application. Then we do the transformation in our provider app and send the data to the OPC UA server. After that, we just need to deploy the flow, and then we can watch the results with an OPC UA client.
Let's start with the modeling. In this example, I want to show you how you can change one variable from the cinematic that it fits into the specification UA for machine tools. For that, I need to install some prerequisites. These prerequisites contain a special node set for the companion specification. For that, I can use the import XML feature of the Siemens OPC UA modeling editor, and I select the node set which is required for UA for machine tools. And now I click open, and then it will import the node set into the modeling editor, and we will have all of the type definitions available. The next step is to create a new namespace. If you switch to the namespace tab, you can see that there are already 5 namespaces after you imported the XMLs. And we need to create a new namespace, and this one will be the namespace we will work in. I call it siemens.org/example machine tool. Now we can start creating our first machine tool. Therefore, I go to the Objects tab, open it and click on Machines, do a right click and add a new instance. I call the machine my machine tool, and the next step is that we need to change the type definition, and we can take the already predefined machine tool type from UA for machine tools. Now we can confirm it, and if you confirmed it, you will see that there is a new instance added and it already contains the facets of the UA for machine tool specification. In our example, I want to create a new channel. For that, I go to Monitoring, Add Instance, and I call my channel Channel 1. And there's a channel monitoring type which comes with OPC UA for machine tools, and I use that as a type definition. If you click on OK, you can see that there is a new instance and there are already some predefined variables to describe the channel, and we need to have a mapping. The mapping is used that the server knows what variable has what name, and we call it My Machine Tool Monitoring Channel 1 Channel Mode. And we can use that name in our provider application to provide the variable to the server. The next step is to export the object model. Please make sure that you select the checkbox to include the mappings and include the values, because that way nothing gets lost. And then we select the name, and I just call it Machine Tool Model, and save it. After the export was successful, you can switch to the directory where you saved it, and I open the PowerShell. You can do that by clicking in the head bar and enter PowerShell, and the next step is to convert the model to the base64 format, and you can use that command. So please make sure to pause the video and to copy the command. And in the quotation marks, I put the name of the XML file, so Machine Tool Model XML, and then I put the name of the target file, which is Machine Tool Model Base64. It takes some time to convert the model, but afterwards you can switch to the directory again and open the model with an editor, and there you can see the base64 encoded object models, and you can copy all of it, and then we switch to the MindSphere, because now we will insert the object model into the configuration of the flow creator. And for that we open the app configuration and switch to code view so that we can do the changes to the configuration. Then we scroll down all the way until OPC UA server config, and there we add a new property called data model, and there we can insert the base64 encoded data model. Please make sure that you don't forget the comma at the end, and then we save the model, and you can check the job progress in the jobs section. And after a short time you will see that the configuration job is finished, and now we are ready to do the actual programming. We start off in a blank flow, and the first thing we want to do is to change the name, and therefore we double click on flow 1, and then we can change the name to Tutorial 4 OPC UA Provider App. After that we can go on and copy the sample flow 2, because it already contains a OPC UA provider. For that we import the sample flow, and then we can switch to the sample flow, select the nodes, and press Ctrl C. Switch to our tutorial flow, and now we can paste it by pressing Ctrl V. Now we only need to do a few changes on that flow. The first change we want to do is that we need to change the variable that we want to poll regularly, and in our case we want to poll the op mode of the first channel, and for that we enter the name of the BTSS variable, which is BAG state op mode. Next step is to change the programming, and for that we open the function node, and then we change the name to transform channel mode. And to have a good fresh start, we delete all of the JavaScript code that was already there, and we start off by declaring the variables. The first one is the cinematic channel mode, and we can read that out of the payload from the parameter service. So we just need to enter the name of the BTSS variable to get the value of the channel mode. The next step is to declare the transformed variable, and in our case I call it UMATI channel mode, and we just declared with null because later we will initialize it with a value. And the last variable is the channel mode string, and this is just an empty string. We will fill it later. And to do the transformation, we use a switch case. So we check the channel mode of the cinemeric, and depending on the value of it, we do the transformation to the UMATI channel mode. So in the first case, this channel mode is 0, and that means that we're in the channel mode jog. And in the UA for machine tool specification, the channel mode number is 2. Then we add a break statement to end the case. And now we copy that and paste it 3 times because we have 4 different modes. In case that the cinemeric channel mode is 1, this means that we're in the MDA operation mode, and that's the same in UA for machine tools. In case that the channel mode is 2, we're in the auto channel mode, and in UA for machine tools, this is the number 0. And in any other case, so in the default case, we have the channel mode other, and in UA for machine tools, it's the number 7. So that's the whole transformation, and now we only add the variables to the message. Therefore, we enter message cinemeric channel mode equals cinemeric channel mode, and the same for the UMATI channel mode. And then we do the same for the channel mode string. And the last step is to return the message with the new properties. After that, we close the function node, and now we can go on. And the next step is to do some visualization. So we use 3 different dashboard nodes to display the 3 variables, and we just use the text nodes. And the next step is to create a dashboard where we can put the elements on. Therefore, I create a new tab, call it Machine Tool Flow Creator Tutorials, and in this tab I create a new group, and the group is called Tutorial 4 OPC UA Provider App. And in this group we can organize our text elements. So first I connect the text elements to the output of the function node, and the next step is to assign the elements to a dashboard group and to give a name to them. So the first element is the UA for machine tools channel mode, and it gets the value from the message UMATI channel mode variable. And now I click done. The next step is to assign the next element to the group, and then we change the name to cinemeric channel mode, and we get the value from the message cinemeric channel mode property. And now the same for the last variable, which is the channel mode string, and we just label it channel mode. And now we have a good visualization of our variables. Before we can deploy the flow, there's one more thing to do, and this is to change the data bus message that will be sent from our provider application to the OPC UA server. For that, we click on the function node, which creates the message object, and there we change the name of the variable R parameter value to channel mode. And also the second thing we need to do is to change the message payload to message UMATI channel mode. So now we have the value of the UA for machine tools channel mode. And then we changed the address to the variable mapping name, and now you can see why it's so important to do the variable mapping in Siemens OPC UA modeling editor. And the last thing we need to change is the value, because now we need to assign the channel mode. And that's it. Now we can click done. And after that, we are ready to deploy the flow. And there's an easy way to check if everything is working fine. So you just need to check the data bus return status and go to the debug section, and it shows status OK if everything is working properly. So there's one more thing we can do, and this is to change the sample rate, and we can do that by changing the repeat interval of the inject node and redeploy it. And now you can see that every second we have a reading operation, so we supply a new value to the OPC UA server every second. And that's the part in the machine tool flow creator. Now I only changed the comment to read channel mode value, and this is the last thing we have to do in the flow creator. And now we can switch to our OPC UA client. In my example, I use the UA expert, and the first step there is to add the Cinemeric Edge OPC UA server. So I click on the plus sign and I select the address of the OPC UA server. Please make sure that you enter the port 48010, and then I use the non-encrypted way, but you can also do a basic encryption. And now I enter the username and my password in order to connect to the OPC UA server. Then I click OK, and now I can click the Connect Server button. After connecting to the OPC UA server, you can see the object model on the left side, and we open the machines object, and there we can find our machine tool, which is called My Machine Tool. And if we open it, go to Monitoring and Channel 1, we can see the channel mode variable which we want to view, and we drag and drop it to the data access view. And as you can see, currently we're in automatic mode. Now we switch to MDA. Now we switch to jog and back to MDA. That was the fourth tutorial of the Machine Tool Flow Creator tutorial series. In this episode you learned how to implement your own OPC UA provider app. I hope you enjoyed it, and I wish you good luck implementing your own app.